In the language of the Storm Prediction Center, the United States government's official severe weather forecasting office issuing a high-risk outlook is not a routine alert. It is the highest category on their 5-level scale. It means that forecasters have reached the level of confidence that a significant, possibly historic outbreak of violent severe weather, tornadoes, destructive straight-line winds, large hail, is not only possible but expected. It triggers immediate action from emergency managers, from broadcast meteorologists, from school districts and stadium operators and transit authorities across multiple states. It means this is not a drill. The high-risk zone that went up this week covered parts of Texas, Missouri, Illinois, and Iowa. Inside that zone sat some of the most populated metropolitan centers in the American interior: Dallas, Oklahoma City, St. Louis, Chicago, Indianapolis. More than 30 million people inside a single severe weather risk polygon that the SPC had not drawn at this intensity in almost a year. And then, before that system had even finished moving through, the next one started organizing behind it. Meteorologists warned that various areas of the United States would go through a weekend with at least 48 hours of heavy rain, hail, flash flooding, and strong wind gusts, with storms sweeping from the Great Plains to the mid-Atlantic coast as weather conditions in those areas continue to favor their development. 48 hours, back to back. In communities where the 4th of July outbreak from last week, 8 people killed, nearly 1 million power outages, PPL Electric calling it one of the 10 most significant storms in its 100-year history, had not yet been fully cleaned up. This is not one storm. This is a pattern. And the pattern is not random. It is being driven by something that is itself growing stronger. With every passing week, the El Niño developing in the Pacific, which has been steadily building the atmospheric instability, the Gulf moisture surge, and the jet stream configuration that makes outbreaks like this one not just possible, but increasingly the default state of American summer weather in 2026, let's go through exactly what is happening, why the system is producing such violent weather, what the most dangerous specific threats are for the next several days, and what the scientists who track these systems are saying about what comes next. Because this week's storm is not the monster they are most worried about. The technical setup behind this week's outbreak is almost textbook in its structure, which is part of what makes it so dangerous. AccuWeather's senior meteorologist Courtney Travis described the atmospheric ingredients plainly. This setup has the potential to produce the most widespread and impactful severe weather outbreak we've seen so far this year. She pointed to a combination of strong high-altitude winds, surging moisture from the Gulf of Mexico, and sharp temperature differences as the primary drivers for tornadoes, large hail, and destructive wind gusts. Each of those 3 ingredients deserves to be understood individually, because understanding how they combine tells you exactly what kind of storms they produce. Strong, high-altitude winds, specifically the jet stream positioned directly over the region, provide the wind shear that severe thunderstorms need to organize. Isolated. Cells, when they encounter a vertical change in wind direction and speed with altitude, begin to rotate. Rotating updrafts are what produce supercells, the class of thunderstorm responsible for the vast majority of violent tornadoes, the largest hail, and the most extreme downburst wind events. Without the jet stream positioned correctly, the convection that develops stays ordinary. With it positioned exactly as it is this week, the same convection can produce rainfall rates of 4 inches an hour and tornadoes that stay on the ground for 30 miles. The Gulf moisture surge is the fuel. When surface dew points across Texas and the lower Mississippi Valley run at 75 degrees Fahrenheit or higher, as they have been this week, the atmosphere is carrying so much latent energy that any thunderstorm that manages to tap into that moisture layer can produce precipitation rates and hail sizes that strain belief. 17 inches of rain fell in one area of Ohio in just 24 hours earlier this month, a total that forecasters described as nearly impossible for that part of the state under normal atmospheric conditions. 17 inches in a single day, on soil that had already been through multiple heavy rain events earlier in the season and had essentially no remaining absorption capacity. The sharp temperature differences, the boundary between the hot, dry air mass pushed east from the southwestern heat, dome and the dense, moist air surging north from the Gulf, provide the lift. When those 2 air masses collide along a frontal boundary, the warm, moist air is forced upward at rates that can generate thunderstorm updrafts traveling at over 150 miles per hour inside the cloud. That updraft strength is what determines hail size. A 2-inch hailstone requires an updraft of roughly 65 miles per hour to stay aloft long enough to grow. A baseball-sized hailstone requires updraft speeds approaching 110 miles per hour. Illinois set a state record for hail size in April, over 6 inches in diameter, from exactly this type of atmospheric configuration. The storm's reach is significant, with major metropolitan hubs like Dallas, Oklahoma City, St. Louis, Chicago, and Indianapolis all sitting within the danger zone. Residents can expect wind gusts of up to 70 mph and the potential for significant flash flooding. The timing is especially concerning for communities in the central states and Great Lakes that are still reeling from last week's storms, which claimed 8 lives. On Tuesday, the threat loomed over the Texas Hill Country, a region still recovering from catastrophic floods last summer. That last detail matters more than it might seem. When emergency managers use the phrase "still recovering," they are describing communities where the physical and institutional capacity to respond to the next event has been degraded by the last one. Road repairs incomplete, bridges flagged for inspection, retention basins and drainage channels still carrying more debris than their normal operational capacity. Emergency responders who worked 20-hour shifts last week being asked to do it again this week. In that environment, the same storm that would be a significant but manageable event for a fully prepared community becomes something categorically more dangerous. People in the threat zone for severe weather should make sure that storm shelters or designated safe rooms are ready, stocked with emergency supplies, and have enough room for all people and pets in case a tornado warning is issued, AccuWeather's Travis advised. That parallel extreme weather story that is the direct counterpart to the storms in the east. While Gulf moisture and jet stream dynamics are generating violent convection from the plains to the Great Lakes, the western states are sitting under a heat dome that has been building for days and is now delivering temperatures that belong in a different country's climate record. Palm Springs, California pushed toward 117 degrees Fahrenheit, part of a western heat dome that forecasters warned would affect millions of people across California, Nevada, Arizona, and Utah through the middle of July. A 117-degree reading is not just uncomfortable. At that temperature, the human body's ability to cool itself through sweating becomes insufficient without shade and airflow. Heat can buckle road surfaces. Power grids running air conditioning for an entire region simultaneously develop demand loads that approach or exceed their designed capacity, sometimes failing in cascading sequences. In the desert Southwest, where many residents depend on swamp coolers rather than refrigerated air conditioning, high humidity days, which El Niño years tend to produce even in historically arid regions, can make those cooling systems entirely ineffective. The geographic split between the violent storm threat in the central and eastern USA and the extreme heat in the west is not a coincidence. It is the same atmospheric pattern expressed simultaneously on both sides of the continental divide. The ridge of high pressure anchored over the west is what is producing the heat dome. That same ridge is forcing the jet stream to bend sharply south and east along its eastern flank, producing the exact wind shear profile over the central plains that is generating this week's severe weather outbreak. West of the ridge, heat. East of the ridge, storms. The same pressure system producing both. Now the part of this story that makes this week's monster storm something more than a single major weather event. What is driving the overall pattern and where it is heading? The monster El Niño of 2026 is causing extremely strange storms all over the world. In China, extremely heavy rainfall caused by a very unusual tropical storm resulted in the deaths of 39 people, with most of the deaths occurring in Hangzhou, where the partial collapse of a reservoir dam sent torrents of water into the city. The same oceanic event that is building the Gulf moisture, surges powering tornado outbreaks in Texas, is, simultaneously, generating the anomalous tropical storm, rainfall that collapsed a dam in China's Guangxi region. The same El Niño, the same excess oceanic heat, different continents, same physical driver. The latest forecasts from NOAA's Climate Prediction Center and the World Meteorological Organization indicate that El Niño conditions are already established in the tropical Pacific and are expected to strengthen rapidly during the coming months. NOAA says there is a 63% chance the event will reach very strong status between November and January. Current model projections show sea surface temperature anomalies potentially reaching between 3 and 4 degrees Celsius above average in key monitoring regions, a threshold historically associated with a super El Niño, a rare event that has occurred only a handful of times in modern records. The WMO said the most rapid strengthening is likely during July through September, the months we are entering right now, with impacts expanding globally through the northern hemisphere in the autumn. The months we are entering right now. The system that is producing the high-risk severe weather outbreak over Dallas and Chicago this week is not operating at its maximum El Niño-driven intensity. That maximum arrives between November and January, when the oceanic temperature anomalies will be at their highest and the atmospheric response to them will be fully developed. NOAA's Climate Prediction Center has specifically noted that El Niño tends to suppress Atlantic hurricane activity by increasing upper-level winds that disrupt storm formation, while simultaneously favoring increased activity in the eastern Pacific. This is the current situation. The Atlantic is quiet. No named storms, no immediate threats. For several weeks, forecasters have described the Atlantic as being on vacation. El Niño is suppressing the basin's storm activity with increased wind shear. But that suppression is not permanent, and it is not complete. The Fox Forecast Center has noted that the stronger the El Niño event becomes, the more rapidly it tends to self-destruct. And since 1970, there have been 5 recorded super El Niño events followed by a swift decline into either neutral or La Niña conditions. When a super El Niño collapses into La Niña, as the historical pattern consistently shows, it collapses fast. And La Niña is associated with the opposite set of weather impacts: reduced wind shear in the Atlantic, warmer than average sea surface temperatures, and conditions that historically produce hyperactive Atlantic hurricane seasons. The 2020 Atlantic hurricane season, the most active in recorded history with 30 named storms, followed a period of La Niña influence. If the 2026 El Niño peaks in late 2026 and collapses rapidly into La Niña through 2027, the Atlantic hurricane season of 2027 could be entering conditions for exactly the kind of activity that 2026 has been suppressing. The monster approaching the U.S. is therefore not a single storm. It is a sequence. The current outbreak, the high-risk tornado and damaging wind event over Dallas and Chicago and St. Louis that has already killed 8 people this month and knocked out power for 1 million households last week, is the immediate threat. Behind it is a weekend system bringing another 48 hours of hail, flooding, and wind to the same geography. Behind that is the peak of the El Niño, arriving between November and January, reorganizing the jet stream, atmospheric rivers for California, active storm tracks for the southern and eastern U.S., and behind that, in 2027, the potential rapid transition to La Niña and an Atlantic hurricane season that will begin with whatever pent-up energy the ocean has accumulated through a year of El Niño suppression. AccuWeather's Travis warned directly, "This setup has the potential to produce the most widespread and impactful severe weather outbreak we've seen so far this year." That is a statement being made in the context of a year that has already produced the most severe spring on record for parts of the upper Midwest. Record hail in Illinois, 8 deaths and nearly 1 million power outages on the 4th of July, 3 UK heat waves before mid-July, Super Typhoon Bavi as one of the strongest typhoons in Mariana Islands history, and 25 heat deaths in New Jersey in a single week. Most widespread and impactful severe weather outbreak of the year so far, and the year has months left to run. The El Niño is still building, and the Atlantic hurricane season has not yet reached its statistical peak. If you are in any of the highlighted areas, Texas, Oklahoma, Missouri, Illinois, Iowa, Indiana, or anywhere along the Great Plains to Mid-Atlantic corridor, the guidance from the Storm Prediction Center and from AccuWeather is consistent and specific. Know where your shelter is before you need it. Have emergency supplies ready. Monitor NWS alerts on your phone with notifications active. Do not wait for a tornado warning to start making decisions about where you will go. In a high-risk environment, by the time the warning sounds, you have between 8 and 13 minutes. That is not enough time to think. It is only enough time to act on a plan you already made. The storm is here, another one is forming behind it, and the system driving both of them is growing stronger in the Pacific by the day. Subscribe and stay with us, because the weekend system is already being modeled, the El Niño updates come weekly, and the Atlantic hurricane season has not yet spoken.